And the reason it looks so like a dog is that it does the same job as a dog, or did the same job as a dog. It ran and hunted prey in the same sort of way as a dog does. And that's why it has the same shape as a dog. Okay, perhaps you could take it now, Bryson. Thank you. The structure inside also resembles that of a dog. This is a dog skull, and this is the skull of the Tasmanian wolf. It's a bit larger, but of course the size of the skull will depend on how big the dog is anyway, and we could easily get a bigger dog skull than this. The only reliable way to tell that this is a marsupial and not a real dog is if you look underneath. Those two holes in the palate there give the game away. Those are the telltale clues that tell us that this is a marsupial and not a real dog. A real dog doesn't have the same kind of holes there. Well, that's convergent evolution among designoid objects. Designed objects, too, sometimes resemble each other because they're doing the same job. Two aeroplanes closely resemble one another, not because of industrial espionage, not because of imitation, but because the wind tunnel is a great leveler of differences. These planes have both been designed for the same purpose, and when you design planes for the same purpose of flying very fast through the air and carrying a large payload of passengers, those planes are going to come out looking pretty similar, in just the same way as the dog and the marsupial wolf come out looking similar. So we've seen convergence between two designoid objects, and we've seen convergence between two designed objects. How about convergence between designed and designoid objects? Well, here is a camera, which is a designed object. And here is an eye, a designoid object. They both do something very similar. They both have a lens at the front, which focuses an image on a light-sensitive surface at the back. In the eye, it's called the retina. In the camera, it is a film. There are detailed resemblances as well. Both of them have an iris diaphragm, opens and closes to regulate the amount of light that goes in. In an automatic camera, the amount of light that goes in and out is automatically regulated by a light meter. It says when it gets brighter, close down the hole. When it gets darker, open up the hole. And the human eye also has an automatic light meter. Now I wonder whether we could have a volunteer to, right, in the front row there, yes, right. What's your name? Gillian. Would you like to take your glasses off, Gillian? Thank you. And come and sit down here, please. Now, what you do, please, is look into the camera there, and they're going to take a picture of your eye, of your iris. What I'm going to do is I'm going to shine this light into the other eye. And I hope it won't be too bright. And what we hope to see is that your iris will contract when I shine the light in. So look into the camera, and I'm going to shine the light. Did you see it contract? Look into the camera. There it contracts. Do you see it? I think it's best perhaps to look into the eye that I'm actually shining the light into. And not you. Look into the camera. Is it too bright for you? No. Okay, look into the camera. There it goes. Do you see it? Thank you very much, Gillian. And there are numerous other examples of living things being exactly the way a human engineer would have designed them. Okay, well, I hope that's enough to convince you that there's something special about living objects. They look designed. They look overwhelmingly as though they are designed. I call them designoid, and I asked you to accept this different title, But it's terribly, terribly tempting to use the word design. Time and again, I have to bite my tongue and stop myself saying, for example, that this Swift is designed for rapid, high-speed, highly maneuverable flight. And as a matter of fact, when talking to other biologists, we none of us bother to bite our tongues. We just use the word designed. But I've told you that they're actually not designed and coined the special word designoid. And I said that there is a special process that brings designoid objects into existence and gives them their apparently designed look. What is that special process? The answer to this question was discovered surprisingly recently in the middle of the last century. One of the greatest discoveries of all time, made by one of the greatest scientists of all time, Charles Robert Darwin. Quite a surprisingly long time after he discovered his principle of evolution by natural selection, he wrote this famous book, The Origin of Species. This is an original first edition, inscribed by the author. Very valuable. Darwin began his argument on natural selection. He introduced it in terms of another process called artificial selection, or selective breeding. All these vegetables here have been bred by human breeders for different kinds of food purposes. There's an ordinary cabbage, cauliflower, red cabbage, broccoli, Brussels sprouts, kohlrabi. Each of these different sorts of plants has emphasized a different aspect of the original wild ancestor, the wild cabbage. So kohlrabi, for example, has a greatly swollen stem. Cauliflower has a greatly enlarged flower. So does broccoli, but in a different way. They're all descended over the last couple of thousand years from the same wild ancestor, the wild cabbage. Now that's the wild cabbage as grown by Bryson. Bryson has many virtues, but green fingers are not among them. Nevertheless, if you were to take this home and grow it for a little while, water it properly and look after it, it would grow up into a wild cabbage. It wouldn't look very like any of those cabbages. That's the point I'm making. They've all come from the wild cabbage, but they're all very different from the wild cabbage. All the breeds of domestic dogs have been bred from the same common ancestor, namely a wolf. Those dogs look terribly different. You'd never think they were members of the same species, but they all in fact come from the same species, a wolf. Now, how do we get, what is this artificial selection, this selective breeding that enables you to go from a wolf to something like that, or that, or that? Well, I'm going to tell you very, very briefly what it is. You start with your ancestor, the wolf. And I'm going to suppose, for simplicity, that everybody on this side of the room is going to imagine breeding for smaller and smaller wolves, and everybody on that side is going to imagine breeding for larger and larger wolves. So in every litter of wolves that we get, if you're on the small side, what you do is you look out for those individual puppies that are a bit smaller than the average. And those are the ones that you breed from. And on this side, you breed from the larger ones. Now, it's going to take a long time. Generation after generation, you mate together relatively small dogs, wolves, and on this side, you mate together relatively large wolves. And after many generations, perhaps hundreds, perhaps thousands of generations, perhaps a couple of thousand years of this selective breeding, because there are genes involved in controlling the differences between the different puppies, cubs, eventually you may end up with something like what I hope is now going to come in.